Eleni. I'm the chair of structural mechanics and monitoring at ETH Zurich. I work in the Department of Civil, Environmental, and Geomatic Engineering. And research focus for our group is the collection of data and their interpretation and use for intelligent assessment of infrastructure. So we basically focus on structures without these necessarily meaning or being confined to buildings, bridges, and the likes, but also wind turbine structures, vehicles, anything that has that is considered a structural system. I'm actually a civil engineer, a structural engineer by training. During my doctoral studies, I came to know or get into this utilization of sensing for assessing condition of structural systems. And since then, I have really been working passionately on this because I found it as an essential next step for the development of civil and structural engineering. And now I see this is actually not an issue of a single domain, but rather an issue that is ubiquitous across domains. And we find ourselves collaborating with people from all sorts of fields. So intelligent is a word that is frequently, or an adjective that is frequently used in place of smart, which is the other definition that is quite popular, and which is there basically to imply that beyond the mere collection of data, we're looking for the functionality of evaluation of the data. We're looking for the functionality of processing, which is really what gives us the power of automating our assessment of engineered systems. So smart systems are the systems that have instilled in them the capacity of perception, but also cognition, understanding, receiving stimuli, but then also understanding their condition and transmitting this to their environment. So there's interaction, there is networking, and there's automation in the process of assessment and decision making, also later on in preventive maintenance and so forth. This then is more focused on the aspect of the sensing. So essentially the technology that enables the collection of data, which should no longer just be doing this task, but also enabling onboard processes that are going a step beyond, that are basically also algorithms that allow us to understand condition and not just simply measure acceleration, but understand there's maybe an impending fault coming up on the basis of this information that is collected. Conventional sensors would just relay the information in its raw form. And then it is on the basis of the person, maybe manually in the past doing the processing, to understand what is the meaning of this information collected. In the smart platform, you now have these tasks that are embedded, these processes and algorithms that are embedded that are doing a lot of the assessment for you. And so, at least in my domain, which is what is called structural health monitoring, we expect these systems to work continuously and to work in an as far as possible unsupervised way. So they have within them the algorithms and capacities to do a lot of the assessment, such as the prediction, detection, and localization of damage, but even tasks that are a bit harder, such as the estimation of residual life, meaning perhaps we're understanding that due to accumulation of fatigue, our system is approaching a dangerous situation, a possible fault, for example. Great balance I find in the combination of testing and simulation, which is not so common. For example, in the civil engineering field, there is a lot of simulation, but we're not accustomed, and testing, but we're not accustomed to extracting data or measurements from these systems as they're operating. We're more predicting on the basis of models. Here, I think wind energy, or at least in the field of wind turbines manufacturing, things are a bit more advanced. There is a balance between testing, simulation, and certification, for example. Perhaps wind energy has fallen into the trap of that development. Now certification processes have reached a mature level, and I, at least as an outsider, I see a reluctance to bring in changes to the system, which might be creating issues in developments. And in this sense, perhaps it's not catching up as fast as the developments on the sensing side and on the automation side and on embedded system side. So what I think wind energy could learn is, or remember from its past, is to basically evolve faster in this respect.